which is, I think, just A and B, one worksheet. But I do want you to find the homework A and B. I think we already went over A, but I still have the homework answers if it would help. But B is the one that we haven't gotten to grade yet because we just practiced the quadratic formula a lot on Friday. Remember you guys had the group quiz? If you guys were absent, it's a bummer. Because totally every group that was in here got 100% because they just needed to eventually get to the right answer. So if you were absent, I mean, we can kind of do it you and me and we can make it up, but it was supposed to really, really help. We do have a few people that need to take makeup quizzes. And so we'll see if we can have time for you guys to do that at the end of class. But a lot of you already came in and took it, which was very helpful. So thank you for doing that on Friday. But you guys see up here on the board. Answers, right? 26, 28, 30, and 32, and 34. Whoa, those answers, they don't look that hard to get. Aren't you just saying how many solutions there are? What was going on in 26, 28, 30, and 32 that was way different? That doesn't look all that hard. Doesn't even look like you did quadratic formula. What were the directions right around here, guys? Determine how many solutions. How are you supposed to do that? Look at your practice test real quick. Can you guys turn to section 9.5? Let's see if I put any hints on the practice test that might be helpful to you. Let's see if I put any hints on the practice test that might be helpful to you. So as you guys looking at section 9.5, is there anything to do with how many solutions? Can you just look under 9.5? Is there anything to do with how many solutions? Has anybody found anything yet? Because in the book it just says how many, and it doesn't say how to do that. In our notes it definitely did, but the book's directions didn't. How about my directions? Find A, B, and C. Oh, wait a minute. Okay, and then does it say anything else about how to find it? Which formula? Perfect. So, as you guys are looking at your practice test, what was going on in 26, 25 through 34, or at least part of that? You were supposed to be using, ready, in your practice test, section 9.5, what is the formula for the discriminant? Remember?
X.
That's the whole quadratic formula. X equals negative b plus or minus, and your focus, square root b squared minus 4ac all over 2a. That's the whole thing. Is there a place to plug in the whole thing? Yes. Okay, let's plug in the whole thing. That's okay. Ready? In your practice test, you're going to need it eventually. Can everybody find it under section 9.5? X equals, how's it go? Negative b plus or minus, hi computer, that's not working. There we go, I don't know. Square root, what goes next? B squared minus
4
AC all over. Got it. Okay, that's the whole, wait, what's that thing called again? Quadratic formula. Circle it, box it, underline it, highlight it. Quadratic formula. That is one you are going to have memorized for the test. And guess what? The test has it just like this. With fill in x equals, and you have to fill it in. Why? Because I give you points for knowing it, and then you have it written to plug into for the next two problems. Oh my goodness, I think this looks a lot like the test. Like last time. With you study it. We have today and tomorrow to work on it. But that's the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Max, I'm coming to you, but I want everyone else to think about, but what's this formula if it's only a piece of that? What's this formula if it's only a piece of that? But Max, what was your question? Oh yeah, one more. This one, and that's the only other formula besides the box process. It is b squared. Oh, he just told us where to look. What is it? B squared. It's just the b squared minus 4ac. That's it. It's just that part. So wait a minute. There's two formulas to memorize, but doesn't this just come out of that?
Yeah, exactly.
So really one, and knowing what other part to look at. So quick reminder in section 9.5, since we're looking at that homework, if a problem says, P.S., the test looks just like this also, where I ask you for the discriminant formula, and I tell you, find the discriminant and then tell me how many solutions. Whereas the book is a little more confusing. Because the book, wrong one. The book just says find the solutions. It doesn't tell you how, but it tells you an example to go look at. But how do you know these answers? Well, what does the test review tell us? Look at the discriminant. Look at the discriminant. So for instance, are you guys looking at number 12? Just for us to do one before we go back to homework? Yeah. Number 12, who's A?
X squared.
X squared is the term, but A is the number in front. 1. Who's B? Negative 12. Gotta be careful. Who's C?
36.
So how do I find the discriminant? If I'm supposed to find D for discriminant, we can do that. Good. So who's going to be squared? Negative 12. Now careful. Some of you do this on your calculator and you make mistakes, and we did on Friday a little bit. What's a negative squared? A positive. So we're going to have 144. Hold on, we're not done. B squared minus 4. Who's A? C. Are you going to have your calculator for the test? I hope so. But I got you for right now. 4 times 36. Any mental mathers out there that can do like a 2-column multiplication? 4 and 6 is 24. Carry the 2. 4 and 3 is 12. Plus 2 is 4. Oh. Whoa! What happens if the discriminant is just 0? Do we have notes where it tells us that the discriminant is like 0 or positive or negative? Not no solution. That's all negative. One solution. Because, plus, we'll look at your quadratic formula. If this is what's under here, the square root gets added and subtracted. 2 answers. But what's the square root of 0?
1. 0.
Just 0. If you add or subtract 0, does anything really change? Exactly. There's only going to be one answer. There's not 1 plus 1 minus answer like on Friday's group quiz, how you added and subtracted and got 2 different answers. Adding and subtracting 0 is just 1. So, how many solutions? 1 solution. Oh, so wait a minute. Over here in homework, as we're grading, anytime there was a 1 solution, what should have happened to your discriminant? It would have been 0. Anytime there are no real solutions, what happened to your discriminant? Which one's 9? A negative. And then 2 real solutions is when you have a positive. So quick reminders. You were looking for the discriminant in each of these. If it was positive, the answer was 2. If the discriminant was 0, you could be writing notes right now, right next to this problem number 12. A good thing to study, not just the discriminant formula, B squared minus 4, not just the discriminant formula, but also what happens if the discriminant is 0 or positive or negative. Hey, I know the answer. Hey, I know the answer. Now hold on, guys. Is all of this in your worksheet notes also? Yeah. If you've been filling them in, yeah. But remember, I'm also showing you what the test is going to look like. Yeah? On this practice test. 32 and 34 might look so different because it went from saying solutions to saying intercepts, but the crazy thing is, if you guys remember, the solutions, the zeros, are the same thing as the intercepts from when we were doing all the graphing at the beginning of the semester. So the cool thing is you could have figured this out by answering or finding the exact same thing. You would have found the discriminant, it would have been 0, that points to 1. Or, in this one, you would have found the discriminant, it should have been a positive number. Sorry, I'm abbreviating for sake of time. You guys are right. And that would have given us 2. So 26 or 25 to 34. What were you supposed to be doing? What's the discriminant? Is it 0 or positive or negative? I know how many answers there are. Yeah? Mm-hmm. But then the end of homework got a little different. True? Now you guys can see the end of the practice test right here. Yeah? What's the end of the practice test say? Solve with the quadratic formula like we did on Friday and Thursday, plugging into negative b plus or minus square root plus or minus 4. So you're being really careful with PANDAS. Okay, sorry, all over too late. Well, no, actually the practice test ends here. Now, I do say to use the quadratic formula, but what's this last section say? Using any method. Is that where homework went to? Okay, so these last ones got a little bit different because it's not just answering how many solutions, it's actually solving, and that's what happened down here in this section where, it says solve using any method. Now, here's what I want you guys to see. Technically, this is supposed to be a grand culmination of chapters 8 and 9, kind of even 7, 8, 9, with factoring and graphing and all kinds of extra things too. The X method, the box method with completing the square, the quadratic formula. So there are some ways that are shorter than others, but only good if you know how to do them. Only good if you know how to do them. Which is why on the practice test, I only put one where I say use any method. Because technically this chapter is saying, do you know how to use the quadratic formula? Do you know how to complete the square? Do you know how to work with radicals? That's this chapter. Radicals, complete the square, quadratic formula. That's the chapter. 3 things. 9-1, 9-3/4, 9-5. But if you guys know factoring, if you're good at graphing, you can bring that in too. But if not, okay, just forget it. It's all right. You'll be able to use either square roots or complete the square or quadratic formula. And so technically in homework, there are different ways of solving these end ones. But the really cool thing is you could have just done this for every single one. You could have just done the quadratic formula for every single one. You didn't have to, but you could. Now, I'm curious though. To hear what you guys use. I'm curious to hear what you guys use. Looking at, what did I give you? 37 to 42. All of them? Oh, I didn't give you these ones. Cross those out. Okay. Does anybody who knows how to factor, did anybody find any good X method ones? Don't worry, if you didn't use the X method at all, I don't mind. I'm just curious. There are some people, and Levi's gone today. He loves to factor, or at least he does it pretty well. Did anybody in their work, or looking up here, did any of them look like they'd be good X method ones? Good. Yeah. Oh, number 40? Actually, number 40 and 38 are really good X method ones, but only if you know how to do the X method. Here's why. Are there any numbers that multiply to be negative 40 and add to be negative 3? Good, Danny. It'd be a negative 8 and a positive 5. So guess what? I could make this, by doing my box pretty quickly, I could make it x minus 8 and x plus 5 equals 0. I didn't complete the square. I didn't use x equals negative b plus or minus square root b squared minus 4ac all over 2a. I didn't have to use that. I got to use the x and go ahead and, like Moses splitting the Red Sea, set each one equal to 0 and say, hey, I have my answers. But even though the X method makes it fast, if you don't know the X method, it's not going to matter whether or not it's fast. What's going to matter on the test is if you know how to do it. So guys, what if you don't know the X method? Who's A? Who's B? Negative 3 though, right? Who's C? Okay. X equals opposite. Andrew, you do that, yeah? Opposite B plus or minus square root. Negative 3 times negative 3. B squared minus 4AC all over 2A. Now, you might have had to do some careful PEMDAS. You end up with 169. Does anyone remember the square root of 169? It's a special one. 13. 3 plus 13 over 2. And 3 minus 13 over 2. That's 16 over 2, which is 8. And that's negative 10 over 2, which is negative 5. You get the exact same answers without having to do the x. So do you have to be using factoring on the test? No. Is it maybe faster for some of you guys that learned the x method really well once upon a time? Yes, which is why homework is saying any method. Maybe there's a method that's easier for you. But if you're like, this only sometimes works, I'm just going to do this every time. It will work as long as you know how to do your PEMDAS, which is why the quadratic formula is something we slowed way down on Friday. Had a group quiz so that everybody saw one perfectly worked out. But kind of worked through the ins and outs of making some mistakes and figuring out what to change, what to slow down, and what to be careful with. And then actually, Kayla, you were pretty good on this one too, because if we had moved the 25 to the other, well actually, you could do factoring on this one, because you could have added the 25 to the other side. You could have factored out. Ooh, actually, you know what? Maybe this wouldn't. If you're not scared of square roots, we actually can factor this down, but a lot of people are scared of square roots. So that one might have been kind of hard to factor. I think what might have been easier on this one is using square roots. And if there's X method by 38, that was probably the easiest. Square roots might be easier here. Because what happens if we divide both sides by -5? X squared equals 5. How can we solve if we have a squared? Radical both sides. So when you have a radical, remember to slow down. Absolute value of x is equal to plus or minus. Ooh, why does it say, oh, it doesn't say? It doesn't say hundredths? You could have taken that to a calculator, but if they don't say take it to a calculator, I guess we're just going to write root 5 and be like, I'm done. Although, actually, to be honest. I should have shown this in 2 steps, and I didn't, and I'm sorry for that. Square roots might have been easier. But if I had used the quadratic formula, and this is the last one I'm going to do for right now, unless someone has any other questions. If I was to use the quadratic formula, I would have needed to have gotten this in standard form. And this would be kind of hard, because who's your A in this one, guys? -5. Who's your B? If we're looking for B and C, and there's only one other number.
0.
Which one's 0? Because there's no x. There's a squared, x squared. There's a number, 25, but there's no b. So we would actually have x equals opposite b, plus or minus square root. B squared, coming to you, Jerry. Give me 1 second. Minus 4ac all over 2a. Yeah, Jerry, what's that? Yeah. Don't get lost. We end up with 20 times 25 and 20 quarters. That's how my brain thinks of it. Every 4 quarters is $1. So every 4 25s is 100 out of 5 of those. You get the square root of 500 all over -20. It would take a little bit of work. We'd have to actually break up the 500 to be 105. I don't know how to square root that, but I do know how to square root that. 10 root 5 all over -20. Oh wait, sorry. That's a -5, not a -10. I'm silly. The 10s end up going away. The 10s end up going away, and I end up with a positive -root 5 again. Technically a negative positive, but either way. Okay. So kiddos, we've talked a lot about the homework that was due today. Only because I know this last section didn't tell you exactly what to do. I just wanted to let you know you could have done quadratic formula in every single one. You could have just practiced the quadratic formula. Kind of like the practice test says, use the quadratic formula. On the test, I'm going to say use the quadratic formula. But there might be a question that says use any method. Could you use the quadratic formula? Yeah. But could some of you show off your completing the square skills? Or your X method skills? Or your square root skills? Yeah. It just kind of depends. Does anybody have a method they think would be good for this one right now? Could do quadratic formula as long as we subtract the 3, but we're already doing that. Any other ideas? X method, square root, complete the square. We could try X method. If we were to try X method, we would still need to get everything to one side, so I would need to subtract that 3 over standard form. X method means standard form. Is there anything that multiplies to be -3 and adds to be 8? trying because sometimes it's a lot faster. But Andrew, sorry, not this time. You could have tried X method and then been like, oh well, let's go to quadratic formula. But is there another way? Isaiah, do you have any ideas? Besides quadratic formula? X method doesn't work. Not for you factors. Huh. We're going to come back to this one. There is another way, but I think we have to finish the whole rest of the practice test first. Tomorrow, we're going to grade section 9.5. I'm going to walk around and check. Section 9.5, worksheet A-B, which is one worksheet front and back. So if you were absent at all, if you were gone at all, please just go onto the Google Classroom YouTube link and make sure that you've made up those worksheets and whatever work we've done. But I'm also grading homeworks A and B. So before I come around tomorrow, today I'm asking last questions on 9.5 A and B. They're back on the board in case you've been absent. 3 through 17, 25 to 34, 37 to 42. Anything else you guys want to see? Just in case you were absent, I can show you the other answers. You were able to grade those ones. But just in case it would help, I do have the other ones. But any other ones that you guys want to see? Okay. So what do you think we're going to do instead? Work on the practice test. Yeah, work on the practice test. So I still have this homework up. If someone is maybe today working on the homework during class at all and you get stuck on something, you can reach out because I have the book up here that I can always turn to whatever you might be stuck on and see if I can help. Let me get all this writing out of here though. It's kind of in the way. Ooh, so it's not going away. There it is. So I do still have this up if you need it. But otherwise, what we're going to is the practice test. Now guys, there's not specifically like a review homework I'm giving you from the book, although there are still those really good questions at the end of the chapter that I could have given you. I think I might have actually even narrowed, oh, nope, that's not what I want. Is this what I want? Oh, there we go. These are really good ones to practice for the test if you guys have some extra time, but it's not going to be your homework. I'm deleting that right now. Our homework is instead just finishing the practice test, and we'll kind of talk through a few things here and there. But if you guys do want some extra practice, I know some of you finished the practice test kind of early, and then the night before the test, you're like, I don't know what to practice. There are some good ones at the end of the chapter, just reminding you of that really quickly. There are some good problems. You take a picture of this. It's in the video from today if you want to come back and access it. There are maybe a couple questions that you don't have to worry about because this test is not with section 9.2. I think in the last time I taught the class, we had 9.1 and 9.2. If you guys look back here, our test, I don't think I wrote it yet, but I'll write it right now. And I think it's on your practice test also, is 9.1, 9.3, 9.4, and 9.5. So here's what I would love to do right now. Not solve every single problem. I need you guys to practice with them tonight. But instead, I want us to go through the practice test and fill in, like Max asked earlier, fill in any important information that we need to remind ourselves of or tell ourselves of. Now, once again, the worksheets have the majority. The worksheets have the majority of examples and hints and tricks. If you guys were taking good notes, well, I guess the smartboard wants to be had right now. That's great and fun. Our worksheets, you guys should have been taking notes all chapter long. Nope. Hi, buddy. So the worksheets have more information. That doesn't mean that we can't do like a short, sweet version here. That doesn't mean that we can't do a short, sweet version here. So let's just go through each of the sections really quickly. I'm going to open the door because it's kind of warm in here. And we're going to write down any hints, any tricks, any reminders that you guys might need as you do this for homework tonight. As you do this for homework tonight. So, section 9.1. Ooh, that was a long time ago. There are no equations. But what do you see? All the problems, 1 and 2 and 3 and 4. Radicals. Radicals. In 1 and 2 and 3 and 4, we see radicals. And so what do we do with radicals? What did I underline up here? It's going to be in the test. It's just not going to be underlined, but I'm still going to have the same hint. Do you guys see any of the ones that could use splitting apart? Yeah. So if I were you, I would draw an arrow from splitting apart to number 1. Number 1 means splitting apart. It was a property of radicals where it said that if you have the radical of A times B, we can split it up to be radical A times radical B, or if we have A over B, we could split it up to be radical A over radical B. Why is that helpful for number 1? I have a big old square root of a fraction that I can split up to be radical top. Ooh, good notes to be taking, Jeremy. Radical top over radical bottom. Splitting up would be great for number 1. Just a quick hint though. When you do split this guy up, that negative needs to stay outside and be a part of the answer. Do any of these need breaking down? What do I mean by breaking down? It's a big number and I'm factoring it, breaking it, right? Factoring tree, or your box method. Do any of these need, like the big numbers that could probably use breaking down? Yeah, do you see that 72? You know what, that's going to get right in the middle of my work. Let's go this way. This way it's not right in the middle of our work. Do we still have room for that one? Draw an arrow to that root 72. That needs to be broken down. Broken down. Quick reminder of broken down. I could do even kind of like little lines to give us room. There was splitting apart. Now breaking down. If I have something like, let's not do 72 because that's the one you're going to practice with. Let's do something like, how about 44? What could 44 break down into? 11 and 4. Do we know how to square root either of those? 4 is the same thing. What is the square root of 4? That's 2 and 2 and 2 root 11. Remember, we can take something that's more complicated and break it down to have a smaller radicand, the thing inside the radical. That's breaking down. What's the next one? Rationalize. Do any of these, rationalize. Do any of these have square roots in the denominator? Which one? Ones. Hold on. Doesn't this guy and that guy both have square roots down there?
Yeah.
Do you remember the difference between rationalizing with a single square root versus an addition or subtraction of a square root? Which one's easier, 2 or 3? Yeah, 2 is easier. What do we always do whenever we have a single square root in the denominator? Same thing. Multiply by that same thing, top and bottom. Multiply by the same thing, top or bottom. So for rationalizing up here, we can say, okay, if we had something like 2 over root 7, we could multiply by root 7 over root 7. On top, it would be messy, but on bottom, we all of a sudden have a squared. And what happens whenever you have a radical and a square? What do square roots and squareds do? Cancel out. But that's not quite so easy when we have a plus or minus. If we had something like 1 over 2 plus root 7, I can't just multiply by root 7 over root 7 anymore. That only works when I have a single root. What do I multiply by when I have a plus or minus? 2. It's the same thing, but I need to do one thing that changes it or that helps me out. What's the sign in between? I have to do what we call the conjugate. I have to multiply by what we call the conjugate. On top, I end up with, if I did have something, I would distribute, but 1 times anything is itself. And on bottom, I get what we call a difference of squares when I FOIL it. And all of a sudden, my problem goes away. And I get 4 minus 7, which is something I can do. Now, guys, I'm just doing little silly examples up here. Do you have great examples in your worksheets? Yes. Should you have good examples in your homework? Yes. I'm just trying to give you a couple reminders of these words, like split apart, break down, rationalize. I see. Give me 1 second. There's one more that says combine like terms, and I don't think we see that yet. But can I just give you a hint that I think eventually this one will need it? We don't see it yet. The 72 hasn't been broken down yet, but I think eventually it'll be helpful. Armando. Oh, I made up an example. So these ones, like the 44, I just made up to kind of help you think about how to do the 72. And then I made up one that looked kind of like this one and kind of like that one. But what we brought in was this idea of rationalizing. So when I say rationalize, the only way to get rid of a square root in the bottom is to multiply top and bottom. So I made up an example where we actually multiply top and bottom, and it brought the radical out. So the process brought the radical out. But this is where math gets crazy, is where things just appear. And if you don't know why they're appearing, you'll never think of doing it on your own. And that's why we have this snazzy word, rationalize, and that's why in section 9.1. 9.1, we did a lot of examples where we're like, you're not allowed to simplest form. You're not allowed to have radicals stay in the denominator. So yeah, Armando, it did look weird. It did look weird, but it's because we're actually bringing something in to help us. Does that kind of make sense? Okay. Those are good hints for section 9.1. I know it got messy, but it's because every single problem kind of needed one or multiple of these little steps up here. 9.1 just said radicals. They get messy. 9.1 just said radicals, they get messy. But 9.3, hold on. 9.3 variables came back. Can anybody look at the examples, 5A, 5B, 6, and 7, and can you remember what we were doing back here? I didn't really write any notes on this one. We're going to put in a couple of hints. What was going on in this section? Before the quadratic formula, before complete the square. Look at those examples. What did we learn in section 9.3? Everest, any ideas? Do you see any common threads with 5A, 5B, 6, and 7 for anybody else?
Parentheses.
Yeah, the parentheses, those were on a quiz that we took a little while back. You guys are going to get all your quizzes back tomorrow, see your mistakes, and be able to ask me questions, study from it. It says it in one of the directions.
No solutions?
No? We learn solutions like all over the place. Yeah, it says square roots, but radicals. What did we learn in section 9.3? If we have something squared with an equals and a number, exactly, Jerry, we can put in, and I wish I had a different color pen. I don't know how to do it in Microsoft Word. But we can put a radical on both sides. Check it. I need you guys to underline using square roots. That's what was new in section 9.3. You should be studying for the test. Remember, guys, a lot of you barely studied the practice test last time. Maybe you did it with me, but you didn't study it. And so even though the test looked exactly the same, a lot of you weren't quite ready for it. Friday, we're going to be, after we take this test on Thursday, Friday, we're just going to have a big old work day. Us as a class, in groups, maybe even moving around the room to work with people that you like working with. We're going to be working on Chapter 8B test corrections all together. We kind of just got through Chapter 9 without needing to really work on Chapter 8B. But we're going to work on test corrections for half points back on Friday. And we'll see kind of the mistakes that were made. But some of you guys, one of the biggest mistakes is the practice test looked just like the test for the most part. You just didn't practice. You didn't study. So write down notes now. But Jerry, you said put a radical in because what does a radical in a square do? But why do we need to write as we go from here? Why am I going to write, but we need to slow it down? We need to put absolute values, right? What's the absolute values? And I'm going to write equals. I'm just going to put, slow it down. We have the absolute values. I'm going to draw an arrow, and I'm going to say, remember, we need to do a positive and a negative, right? Yeah. 5A? Well, we can kind of peek at 5A and 5B. I might not answer it totally. But here's what 5A and 5, because it's not even solved, right? That's 6 and 7. 5A and 5B just says how many. Wait a minute, guys. Can we talk about this right here? Ready, Max? This number that's underneath, how many solutions? Ready? If positive, then. If 0. Hey, we kind of just talked about this a second ago, just in a different context. But maybe we can have the same thing apply. If the squared is a positive number, like 5a, how many solutions? 2 solutions. If the number is 0, how many solutions? Is that cool? And then if negative? Has anybody yet put a negative number and tried to do a square root in their calculator? It doesn't work. It says error. That helps on the test. If you forget, you can always try to square root a negative and ask yourself whether or not it's going to work. But Max, I think that's all you need. So remember for 5A, 5B, just fill in how many. I'm not giving a lot of answers today because we're going to go over answers tomorrow, if that makes sense. I'm going to have you guys work on it tonight. We're just trying to do really good things to study and remember for each section. And guys, on the test, I'm not going to have 9-1 and 9-3, but is it going to go in order? Yeah. So if you're studying this, and if you're remembering this section, I need to do splitting apart, breaking down, rationalizing. This section, I need to put in square roots. I'm hoping that helps your brain kind of know what to do when it comes to a section on the test, yeah? But Max, great question. Great question. The only other thing that I would write as a note is get the squared alone first. Then, what do I mean by that? Don't take a radical of the squared until you get it alone. Meaning, on number 6, are you supposed to put a radical right now? On number 6, should you put a radical? No, what should you do first? Move. And how do you legally move a subtraction? Addition. Good. You need to get the squared alone first. Number 7, can I put a radical right away? It's tricky. Yes. Yeah, because the squared is already, there's no extra plus or extra minus. I need the radical right away to undo the square. Some of you will see a couple mistakes on the quiz you get back tomorrow having to do with section 9.3 and when you took the radical. That's why I wrote the note. 9.4, what was different in that section? Oh, you guys half liked this one. You half liked this one. A lot of you know how to fill the square. The things that we need to probably look at tomorrow is the factoring part, which you'll see on the quiz. Most of you can complete the square pretty good, but the factoring part, and then the solving using it. The nice thing is on the test, though, guys, I wrote the squares because I can give you points for filling in the square right. We need to talk about tomorrow the factoring and then the using. But the nice thing is, 9.5, we just filled in our notes for, right? We filled in the discriminant. We filled in the quadratic formula. So I think you guys are set up for success as far as fully attempting this tonight. So what should you probably treat this kind of like? A test. But do you have some notes to kind of help you think through things? Yes. Do you have worksheets to go back and check out similar problems to? Hopefully, yes. And if you're like, well, mine aren't so great, you can use my videos. But tonight, what's the homework? What are we doing tomorrow? Grading it and finding and fixing mistakes before Thursday. Sound good? If you guys need help, come on in. Find me. I'd love to help. See you guys later. It's chocolate. See you guys in the gym. Please, please, please. If you're stuck, if you're behind, come find me. Let me help you.